In this video, we're going to define what we mean by an anomaly, and then we're going to see how this affects various different measures of average that we've looked at before and what we can do about that. So let's go back to the example of a cricket team, okay? And I'm just going to put in some scores. So the first guy gets 172, okay? The next guy picks up 30, then someone gets 27, 35, 11, 15, 7. How many have we got here? 1, 2, 3, 4, 5, 6, 7. Well, not everyone has to play, so we'll just do one more. And that will be a 9, 20. Okay, so if you look at all this data, all these values from here to here are pretty similar. Okay, they're comparable. And then we've got this crazy value out the front, this 172. We call this an anomaly. Anomaly. That's supposed to be a Y. Terrible handwriting. Anyway. So what do we mean by anomaly? Well, it's just a data point that's completely different from the rest of the data. And we have to consider this because if we're talking about the average of this data, well, this data point here, this 172 of the cricket score, that the player who scored that is clearly not the average player in this team, all right? So all these guys, pretty all right scores, but they're all similar to each other. They're all close to each other. I'm sure, obviously you're inferring all this, but the next week the guy who got 27 get more than the guy who got 35. Whereas this result here is either extreme luck from one of the guys on this one weekend, or they're just a brilliant player who shouldn't be in this team. Okay, so they're an anomalous result. When we're calculating the mean, if we look at a mean formula, so the mean, we add them all up, so 172 plus 30 plus 27 plus 35 plus 11 plus 15 plus 7 plus 20. That's over the number of data points we have to 1, 2, 3, 4, 5, 6, 7, 8. Alright, if I just calculate that, it's going to be a lot bigger than a lot of the average points because of this anomalous result that's so high that it's dragging the mean up. Alright. Okay, so the mean comes out as 39.6. Okay, but that's bigger than every single data point other than 1. Okay, so that's bigger than 7 of the data points and less than 1. So we can't really say that's a measure of central tendency because it's nowhere near the middle of the bulk of our data. So sometimes if it says question might be calculate the mean, what might be the problem with this mean? You can look for anomalies and try to talk about those. Or it might say work out the mean, factor in any anomaly. And what we would do there is if we wanted to find the mean and just ignore the anomaly, we would not add the 172 and then we would just divide by 7. Okay, we just work out the mean of these 7 data points. Now, if we look at the median, so to find the median, first we have to put them all in order. So we get 7, 11, 15, 20, 27, 30, 35, 172. I want you to think about, is the median effective? Is the median still as good a measure of central tendency as it was before? So I'm not saying is the median good or bad, but is it affected by this anomaly? Think about how we calculate the median. And the answer is no, really it isn't. Because of the way we calculate it, because we're crossing off all the extreme data in this style, the only data that really gets factored into the median by its definition are these middle points. Okay? So we've got 27, so I'll do 20 plus 27 over 2. That's equal to 47 over 2. That is, sorry, let's type it. 46 over 2 is 23, so that's 23.5. Right, and that is actually quite a good estimate of the centre of our points. And it would be, what my point here is, if this higher score was a less extreme score, say 40, we would still get the same value for the median. So it doesn't really affect it. And again, even if this score was somewhere in the bulk of the data, it would have to be somewhere between 7 and 35, and the only way it would affect this is if it was between 20 and 27, in which case we'd still get this median quite close, right? So the median would still be pretty similar. So the median is not really affected, but as you can see, the mean is drastically affected by anomalies. Lastly, the measure of spread. The range, of course, is massively affected. The range of these 7 points would be 35 minus 7, 28. Okay? The range of all of the points would be 172 minus 7 would be 165, which states that there's massive, what's the word I'm looking for, spread in the data. There really isn't. Most of the data is very close together. It's just this one point. So that is a problem. If you get asked what a problem with the range is that if we have an anomalous result, it can make it seem like the data is really spread, when in fact it's just one data point. That's an anomaly that's miles away. Okay, the range is very heavily affected by anomaly. And if you do go on to study maths, as you get older and older, you'll start to see, especially if you do stats-based stuff, that there are better measures of spread of the data, but for now, ranges, the only one that's easy enough to calculate, I guess, for your level, which is fine. But yeah, as long as you're aware of the downfalls of it, and you can state these, then it's perfectly fine to not know any methods. Now that is it for this video. Yeah, if you did enjoy it, please be sure to like, subscribe, and I hope to see you in the next